Alright, so welcome back. In the previous pages, we have chosen the formal description of this a priori algorithm for you already. Right? I hope you can understand me and you can follow me in this description for the algorithm. This algorithm is very important because, no matter when you learn the databases courses, they will always talk about this algorithm in the very beginning for the data mining course. It is a very important algorithm actually. So make sure you can follow me, for the algorithm, and also make sure you can understand this algorithm very well and try to use it to for mining some frequent patterns with some examples on your papers after class. And then in this page, we want to further describe some potential improvement of this algorithm for you, because according to the previous description, you will find this algorithm also contains some challenges or some weaknesses. So in this page, will show you with several major computational challenges with this a priori method. So according to the previous pages, for the method, we may have to scan the database system multiple times, because for each of these iteration, right, we need to scan the database system to count the appearance of its patterns in the tables, right? The first scan, the second scan, the third scan, the fourth scan, and the k scan, right? In other words, we have to scan the database system multiple times depending on how many iterations we run this algorithm. This kind of scanning can be very time consuming, right? Also, we will have a huge number of candidates in the mining process. We will start from the patterns with one single item to the patterns with two items, with three items, and it goes forward, right? According to the previous pages, we mentioned, given the data sets with n items, the patterns we can generate for the candidates actually can be 2 raised to n minus 1, right? It will be a very large number, even though we have this a priori based pruning principles as well as other pruning methods. The pattern candidates we can generate can still be very huge, right? Also, the workload for the mining process can be very tedious. Of the supporting counting of the candidates, we have to count this candidate multiple times by scanning the database system, and this counting can be very tedious and very boring actually, and also very simple, right? This will create some problems when we are applying this a priori algorithm to mining the frequent patterns on database system with a larger number of candidates or larger number of items, which will be very time consuming. And we may have some ideas to further improve this a priori algorithm, and in this page we show you with some general ideas. So, for the first challenge, probably we may consider to reduce the passes of the transaction of the database system scans. In other words, before we have to scan for the database system in each iteration. However, here we may consider to reduce the passes of the scans. And also, before we mention we have not so candidates, and we may consider to shrink the number of candidates as well for improving this a priori algorithm. As to the counting process, we may consider some methods to facilitate the support counting of candidates. So these are general ideas, and we can show you with the example about how to reduce the scanning cost. Because before we mentioned, for each of the iteration, we may have to scan the database system once, right? And it will be very time consuming. Here we propose to further improve this algorithm by scanning this database system only twice. So, to achieve this target, we may have some assumptions, right, or some observations. In this page, we show you with the observation, which can serve as an assumption for the method we show here. And we have an observation that any item set that is potentially frequent in database must be frequent in at least one of the partitions of the database system. So here we can propose to partition a large-scale database system into multiple parts or multiple partitions or multiple subsets. And if we say that item set will be potentially frequent in the overall database system, then it should be at least frequent in one of the partitions, right? If this pattern is non-frequent in any of these partitions, then it will be impossible for this item set to be frequent in the overall database system, right? So therefore, based on this idea, we can further propose a method to improve this scanning process of this algorithm for this mining the frequent patterns. So we propose to partition the database system into multiple subsets. Now, if we have DB, we can partition it into DB1, DB2, DBK, right? And the joins of them together will be equal to the overall DB. And if we plan to mine some frequent patterns, we can partition the database system and also find local frequent patterns. For each of the DB1, like DB02, and DBK, we can mine its frequent patterns based on internal transactions only. The time cost will be much lower because we only have one subset of the transactions in each of the partitions, right? So based on each of the partitions as well as the frequent patterns we mine based on each of them, we may consider to consolidate the global frequent patterns based on them by integrating them together with a further scanning, right? So you can see, when we are mining the patterns, frequent patterns based on this partition of the database system, we may only have to scan this database only twice, actually. The first scanning will be based on each of the partitions, and the second one will be based on the overall database system for the scanning, which will be much faster, actually, as we have larger scale database systems. Okay, so this is the way we can consider to further improve a priori algorithm when we are dealing with larger scale database systems. To the other challenges, we may also have some methods to handle them, but we will not mention them in the class, and you may check the textbooks for more information.